So we have our balanced chemical equation, and we are told that we have 255 milliliters of the material barium hydroxide. Now this is a base, so we have a base. But if I follow on in the question, I'm asked, we want to know how many milliliters of the other material of the acid, which in this case is H3PO4. I can use dimensional analysis to figure this out. So, well, we're in the units milliliters, so I need to go, let's see, 1,000 milliliters of Ba hydroxide 2 is the same as 1 liter of barium hydroxide 2. That will get me in the units from milliliters to liters. In this case, I'm going to put 1,000 milliliters of barium hydroxide in the denominator, and I do that so that these cancel. But that leaves me in the units 1 liter of barium hydroxide. Next, I am told that the barium hydroxide, for every 1 liter of barium hydroxide, I have a molarity, or the number of moles, is 0.250 moles of barium hydroxide. Now I can use this fact, 1 liter of barium hydroxide (0.250 moles. Moles of barium hydroxide. I do this so that the liters of barium hydroxide cancels with the liters of barium hydroxide. At this point, I'm ready to go to Moletown and correlate the number of moles of hydroxide with the number of moles of, the number of moles of hydroxide with the number of moles of H3PO4. So I see from my balanced chemical equation that for every 3 moles of barium hydroxide, I only need 2 moles of my H3PO4. So let's see, I have moles barium hydroxide, so there's going to be 3 moles of barium hydroxide for every 2 moles of H3PO4. And I do this so that the moles of barium hydroxide cancels with the moles of barium hydroxide. Now I've successfully made it through Moletown, but now I just need to get moles into the units milliliters, and I should be done. And so for every 1 mole, 1 liter of H3PO4, I'm told that I also have 0.250 moles of H3PO4. This means I need one additional box, and I will put the moles on the bottom, 0.250 moles H3PO4 for every 1 liter of H3PO4. And I do this so that moles cancels with moles. Now I've kind of run out of boxes. I know I'm in liters and I need milliliters. I'll do one additional math step after I've done all of this math. So starting here, the math that I'm going to do, I'm going to kind of circle back around here, is 255 times 1 times 0.250 times 2 times 1, all of that over 1000 times 1 times 3 times 0.250. When I simplify the top, I get 127.5. When I simplify the bottom, I get 750. When I simplify that a little bit further, I get equals 0.17. In this case, liters of H3PO4. But if I want to turn it into milliliters, I can shift the decimal point to the right 3 times for milli. So that's 0. Whoops. So that means that the decimal place keeps going that way. So 170 milliliters of H3PO4. And just to make things, I have 2 sig figs here, but then in my molarity, I have, what am I saying? I have 3 sig figs here. And I have 3 sig figs here, which doesn't do anything to the number. 170 milliliters. H3PO4.